Hey guys, this example is going to be for problem 3 in MyStatsLab for week 9. We're going to go ahead and look at this problem 3 example, work it out for you and see if it'll help you out. Now in the problem we're looking at average time that students spend per lab visit, and we have 12 random sample lab visits that we have the times here. And part A of this problem asks you to plot the data and are there any observations, outliers. So let's take a look at this. So for this problem we're going to build a histogram. Now if you remember from earlier in our class, we did histograms, and as a matter of fact I posted a link to a screencast video of how to work the histogram, which you can refer back to that. I'm going to go through it fairly quickly here just so we can get this part of the problem done, but we will go ahead and create a histogram. So we're going to go to Insert, a pivot table. We have our times highlighted there. The range is here, so we're going to click OK. Now from here we're going to click on our time in the lab, go down to where the values are, left click there, left click on value field settings, and we want to change this to count. Click OK. Now we can drag our time in lab down to row labels. There we have our numbers there and the counts for each one of these. We'll click on this cell here so that we can go up, click on group field. Now there's where we're going to do our groupings. Now for this one we have some very low and some very big numbers, so I'm going to change this to start at 0 and end at, I think our biggest number there is 125, so we're going to end at 130, and we're going to put this, our bin size, at 5. Click OK. There we have our bins, and you can see a lot of them have been eliminated. We go from 0 to 4 to 4 to 44. Pretty good grouping in here, and then we go from 74 to 125. So you can pretty much see what's going to happen already. But we can go ahead and build a histogram. Click on Insert, Column. We'll do a 2D column, and we'll wait for our histogram to show up. There it is. Get rid of this box. See if we can slide this down a little bit out of the way here. Now if we want to go ahead and put these all together like our normal histogram, we can click on this bar, left click, and now we can right click, click on Format Data Series, and then we'll take this gap width, take it to 0, close this, and there's our histogram. Now the only thing here is we left out a lot of space here and a lot of space here. I'm not going to put those in there, but we can tell right away that we do have a couple of outliers. One in the 0 to 4 range, which is the 4 here, then one in the 125 to 130 range, which is the 125 that I have here. So we can tell that there are 2 outliers here, one on each end of our histogram. Now that's part A. We'll go down here and click on our part B tab, and we'll take a look at that. This is a lot like what we did in the problem 2 screencast that I made a day or two ago. But we're going to go ahead and we are asked to do 95% confidence intervals, and we're going to first make one with all of our data. So I have our same data that I copy and pasted from part A here to part B. Now, with this problem, we're going to also need to find our mean, y bar, and our standard deviation, which weren't given to us. So I started making my list of our data here. N is 12. We have 12 pieces of data, 12 in our sample, but we need to know what y bar is, what our mean is. So if I click on my cell here, you can see what I did. I took the average, used the average solution there in Excel, highlighted my data, A3 to A14. So we would use equal average and then A3 to A14 just by simply highlighting our data there. Click on enter and it would give us the mean, y bar, which is 55.083. Now we also need the standard deviation. So same thing here, I use my Excel formula, equal STDEV, highlight my data again, click enter, and I get 27.550 for my standard deviation. Now we need to end up here with our margin of error, but with the data we have, we can first start off by getting our standard error. And our standard error we can get because now we have our standard deviation and we know what our n is. So in this cell I put equal D8, which is our standard deviation, divided by the square root, so using SQRT, our Excel formula, and then click on our 12, enter again, and we get our standard error of 7.953. Now we also need our critical value. If you remember from our last screencast, we used the 10V to do that. So here again the same thing, equals 10V. We're looking for a 95% confidence interval, so we use 1 minus 0.95. We also need our degrees of freedom. With a sample of 12, we use 12 minus 1. Click enter, and it gives us our critical value of 2.201. Now we have everything we need to calculate our margin of error, which is simply D10, our standard error, times D12, which is our critical value that we just calculated, and we get our margin of error, our ME, is 17.504. Now that we have that, we can complete our interval. Our lower spot on the interval is going to be y bar, the 55.083, which is our D5 here, minus our margin of error, 17.504, and we get our lower limit of 37.58. Calculate the upper limit the same way, using our mean, our y bar, 55.083, which is D5 plus D14, which again is our margin of error, and we get our upper limit, 72.59. So we can say the confidence interval, including our outliers, 37.58 to 72.59. Now the second part of part B in this problem asks us to do the confidence interval without the outliers. So I basically took the same data, left off those two outliers, the 4 and the 125. Now I have a sample size of 10. And we have to go back and recreate our y bar, which is the average of the 51 through the 64, leaving off the two outliers, and we get a new mean of 53.200. Same thing, standard deviation of this set of data without the outliers, we get 9.520. So again, recreate our standard error, by taking our standard deviation and dividing it by the square root of n, we get a standard error of 3.010. Now we can go ahead and calculate our new critical value with our 10V. Still 1 minus 0.95. We're still doing a 95% confidence interval. But now we have 10 minus 1 to get our degrees of freedom because our sample size is 10. Click enter again, and there's our new critical value of 2.262. And with that, we can go ahead and calculate our margin of error by using D36, our critical value, times D34, the standard error, and we get our margin of error this time to be 6.810. Just about done now. We can create our lower interval confidence interval point by taking our new y bar 53.200, subtracting our margin of error 6.810, formula here, we get 46.39. Also calculate our upper limit by taking our y bar 53.200, adding our margin of error of 6.81, and we get our upper limit at 60.01. Now we can say that 95% confidence interval, excluding outliers. This should be excluding right here. Let's change that right now. We'll say not including outliers, 46.39 to 60.01. So there you have it. Problem 3 from MyStatsLab. Calculated our histogram, found our 2 outliers, then we calculated our confidence interval using both the outliers and without the outliers. So I hope this helps you with your problems we have this week. And of course, anytime you have any questions, just post it in the confidence area, send me a private message. I'll be getting back to you as soon as I can. Thanks.